This extraordinary journey begins aboard the 40,000 deadweight bulk carrier Hansa Naree, proudly owned by Precious Shipping of Thailand. Across the global maritime industry, bulk carriers transport countless commodities every day: ores, fertilizers, grains, and more. But every once in a while, a cargo arrives that is far from ordinary. A cargo that is not just material, but a story, a learning opportunity, a rare glimpse into the future of energy and science. Today, we dive into one of the most unique cargoes any bulk carrier can ever carry. Ore nodules, also known as polymetallic nodules, small, dark, potato-sized rocks formed at the deepest, most remote parts of our planet's oceans. Deep beneath the ocean's surface, at depths of 4,000 to 6,000 meters, lies a world humans have barely explored. Near freezing temperatures, crushing pressures up to 600 times that at sea level, and perpetual darkness define this extreme environment. In these depths, ore nodules slowly form. Metal oxides, such as manganese and iron, precipitate from seawater, coating tiny objects like shell fragments or shark teeth. Layer by layer, over geological time, these coatings grow into the nodules we see today. The growth is unimaginably slow, just 1 to 10 millimeters every million years. A nodule the size of a human fist may have taken tens of millions of years to form, long before humans learned to write, build civilizations, or even walk upright. Although they look like ordinary stones, ore nodules are rich in metals critical for the world's clean energy shift. Nickel, key for high-energy EV batteries. Copper, essential for wiring, renewable energy systems, and electric vehicles. Cobalt, improves battery capacity and lifespan. Manganese, vital for advanced battery cathodes and steel alloys. As global demand for clean energy surges, from electric vehicles to grid-scale battery storage, these metals have become strategically important. Countries and companies are now exploring new sources beyond land-based mining. This is why ore nodules have become a topic of global interest, scientific research, and debate. Harvesting nodules from the ocean floor is no easy task. Human divers cannot survive these depths, so advanced underwater mining systems are required. These machines, resembling giant harvesters, move slowly across the seabed, collecting nodules and sending them to the surface through long riser pipes. The technology remains experimental and is internationally regulated by the International Seabed Authority, ISA, under the United Nations Convention on the Law of the Sea. Countries like Japan, South Korea, India, Germany, and France, along with US research institutions, have conducted pilot extractions and small-scale shipments to study their commercial potential. Recently, the bulk carrier Hansa Naree transported a rare cargo of ore nodules from Altamira, Mexico, to Moreau, USA. This is not a normal trade. This cargo is part of a scientific and industrial pilot project, one of only a handful ever handled worldwide. The crew is not just carrying stones. They are carrying millions of years of planetary history. They are carrying the future of material science. And they are contributing to a global study on the next frontier of critical metal supply. At Altamira, loading required precision. Nodules vary in size, shape, and moisture content, and may not flow smoothly. The crew monitored flow, distribution in each hold, dust or sediment, and cargo surface condition. Every nodule is slightly different, requiring careful trimming to ensure proper weight distribution and vessel stability. Once at sea, monitoring continued. Ore nodules can shift differently from traditional ores, especially in heavy weather. The crew observed cargo movement, compaction, moisture, and pressure against bulkheads and hopper walls. This voyage provides invaluable data on cargo behavior during ocean transport, shaping future guidelines, safety protocols, and risk assessments. The crew monitored the flow and discharge operations closely from the start, ensuring any blockages or slowdowns were addressed promptly. When the ship arrived at Moreau Port in Louisiana, right on the Mississippi River, unloading quickly turned into a real challenge. Nodules vary in size, shape, and moisture content, causing arching or bridging inside the hold, slow or unpredictable flow, sediment accumulation in corners, repeated adjustments of discharge equipment. Close coordination with the terminal ensures smooth flow and safe movement. After discharge, hold cleaning is more complex due to sediments clinging to surfaces. All observations feed into the company's growing knowledge base for future operations. From the silent depths of the ocean floor, to the conveyor belts of Altamira, to the holds of Hansa Naree, to a port in the United States, these nodules have traveled an extraordinary path. Our crew has played a key role in a global scientific journey touching geology, engineering, environmental science, maritime expertise, and the clean energy transition. This voyage is not just a cargo operation. It is a story of curiosity, learning, and pride. A story we are honored to share with our colleagues, partners, seafarers, and the world. Because sometimes, a cargo is more than just a cargo. Sometimes, it is a window into the future.